Hey class, this is a backup of our center of mass class we had last week. I noticed when we did it, we did not have a lot of questions, so I didn't remember to post all of this. But just in case you're wondering, there is a YouTube video about kicking a football with a robot, which is a great moment where you can see the ball being struck and how much it's compressed and that force over time as a function of frames per second. We also happen to talk a lot about the Mars lander, Perseverance. I'm not going to show up on the AP exam, but definitely a cool moment in engineering and science and space exploration. So what we are going to talk about is center of mass, which again was a good model for how do we calculate momentum. And center of mass, whether we're talking about a Mars lander or an iceberg or a person or a football, any of those types of things, the height and distance is always going to be measured at the center of mass of the object, and the center of mass or center of gravity is defined as the point around which the object is evenly placed. Okay, so we talked about the meter stick and some of those other points and how they are all balanced across a singular point. Okay. Notice you can take any point to be your reference frame, and from there you can measure all of the other coordinates. I always like to pick one of the masses as my reference frame because then my x value is 0. One less thing I have to calculate. Okay, we then talked about how we can add each individual component together. So this could also be m3x3 plus m4x4 plus m5x5. We can keep going on, and this is often abbreviated the lower number as just capital M for all of the masses summed together. Okay, so we see that as all the masses, the total mass is m1x1 plus m2x2 plus m3x3, and we just keep going on, and this slowly points us towards the direction of calculus. But we're not going to do that this year. We're going to stop at this point, but it does set up the system that we can eventually use more complicated mathematics. Okay, and we could say the same thing in the y direction and the z direction. So in 3 dimensions, we can figure out the exact center of mass of any object. And in fact, in physics, we're going to treat pretty much every solid object as a point at its center of mass. So whether it's more famously, there's always a discussion of a spherical cow. Okay, we're just going to treat it as a point at one center of mass, and then we can ignore its legs and horns and hoofs and all the other pieces because it's all connected to a rigid system, and most of the physics is going to be true for that individual point mass. Okay, and then we can see we can apply the same thing to NASA and to airplanes and how fuel is pumped and transferred around the different points. Interestingly, you'd think this would be the one institution that would use mass instead of weight, but for some reason they use W for weight, when in fact, of course, if you go into space, the weight would be reduced, but the mass would remain constant. Okay. And again, we could pick any reference line, which led to later this week, we saw MC Hammer, of all people, talking about the measurer being a part of the measurements. And that's true here as well. Okay, so just a little summary of last week's notes. And of course, as always, taking questions via email and during storm time.